Hello there, everyone, and welcome back to the Math Puzzle Crash Course. I've got a little simple problem here, a mixed operations problem. A little unusual one from the normal one, and I'd like to make sure you read this one carefully. But it's 4 plus 3 times 0, but is it really 0? It's 0 factorial equals what? So I'm kind of giving it away by that, but if you'd like to, you can pause the video here and we'll come back and work it out together. All right, so hopefully you've had a chance to think this one over. A lot of people will give the answer 4 because when they're reading the problem, they see the 0 with the exclamation mark, and they're just assuming it's 3 times 0. So 4 plus 0 would be 0. And, if you didn't have the exclamation mark, I would agree with you. But if you remember your mathematics, if you remember anything about factorials, and you may or may not have worked with them, honestly, a factorial is kind of it's a man-made thing, really, used to kind of as a shorthand convention for some repeated multiplication, but it really shows up more in things like permutations if you're dealing with those. So, it's something that not everyone's super familiar with, but if you remember anything about what 0 factorial is equal to 1. And I know that might be a confusing concept for many, but really what you've got is since 0 factorial is equal to 1, and 3 times 1 is 1, then you're basically adding 4 plus 3, which is 7. So the correct answer is 7. Now, I know a number of people remember this, and they're fine with that answer, and there's a pretty good number of people who are still thinking it's 4, because I've seen a lot of people answer 4, regardless. Now, we're going to go back and cover what is a factorial. So first of all, and I saw someone else explain this online, but 0 with the exclamation mark is more than just an excited 0. I really loved that explanation. It was kind of funny to me. Maybe not funny to you, but it was funny to me. It's a factorial. Now, if you recall, and you may not recall, depending on how much of this you've had, but if you have a variable x factorial is equal to x times quantity x minus 1 times x minus 2 times x minus 3, and so on, and you keep going until eventually you're going to be multiplying by 1. All right? So, for example, 3 factorial is equal to 3 times 2 times 1. 2 factorial is 2 times 1. 1 factorial is 1, just 1. Um, and of course, what 0 factorial is equal to 0. Is equal to 0? But no, mathematicians have actually chosen 0 factorial to be equal to 1, which is fine. It's a convention. I mean, the whole idea of a factorial, it's a man-made thing. It's basically used because, if you have something in a permutation, if you have 5 people and you have 5 chairs for 5 people to sit in, and each person, you've got, Sam, Sally, Harry, Fred, and Mike. Well, when you figure out, how many people can sit in that first chair, well, you have 5. And then once that person's seated, how many people can sit in the next chair in order? Well, you have 4 people left, so it's 5 times 4. And you get to the third chair, how many people are left? How many possibilities can sit in the third chair? Well, there's 3. And then you finally get down to the second to last chair. You have 2 people left, so there's 2 possibilities. One of 2 people can sit in that chair. Finally, when you get to the fifth chair, you have only one person left, so there's one possibility. So it's you when you figure out all the possibilities, it's 5 times 4 times 3 times 2 times 1. 5 times 4 is 20. 20 times 3 is 60. Times 2 is 120. So there's 120 permutations or 120 different scenarios that you could have for those 5 people to be sitting in those chairs. And so it's a man-made convention, but it's much easier to write 5 factorial, 5 with an exclamation mark, than it is to write 5 times 4 times 3 times 2 times 1. And I know if you've watched any of my other videos in the past, I've always harped on what multiplication is. Multiplication is shorthand for repeated addition. Well, a factorial is a form of, excuse me, shorthand for repeated multiplication. So it's the same kind of concept. Now, I know the idea of 0 factorial being equal to 1 is still confusing. But again, I'm going to say it again. Keep in mind that mathematicians have invented factorials as a useful operation. That's just simply a shorthand method for repeated multiplication. Um, and in fact, if you look at it, factorials fall into the order of operations convention, and the factorials have a precedence that is above multiplication and division. For example, if you look at something like BODMAS, which is a familiar acronym that many are familiar with, you've got brackets, orders, division, multiplication, addition, subtraction. The O is for orders. Orders is kind of a generic term that represents exponents. It could be square roots, factorials, basically anything that is a shorthand for multiplication. Now you've also got PEMDAS, which is more a common acronym used in North America to remember. Yes, these are just memorization tools. Not everybody has used these memorization tools. The order of operations has been taught uh, for a very long time, anybody's lifetime that's watching this video. It's not an issue at all. But the acronyms, they're maybe a little newer. I don't actually know exactly when these started. But in North America, PEMDAS is often used. Some people will even say, like, please excuse my dear Aunt Sally to remember these letters. But the E in this is for exponents. Now, exponents is not the best term. I like orders better, actually. Orders is more generic, covering everything. But when you have the E for exponents, it really does include exponents, but it also includes the square roots, the factorials, anything shorthand for multiplication. So that's a little bit off topic, but BODMAS and PEMDAS are describing the same order of operations. That's a whole different thing that I get into in some other videos. I won't cover that all here. But yeah, it's been decided by mathematicians, since the whole factorial thing is a man-made operation, it became useful to make 0 factorial equal to 1. Now, I've seen people like complain about 0 factorial being equal to 1. I've even seen one person insist it's lazy of mathematicians to make that up. There's nothing lazy about it at all, provided you understand anything about permutations. And again, um, I discussed in here before about, 0 factorial is 1, what the idea of 3 factorial is. But if you explore what permutations and combinations are all about, it does make sense. You've got this generic formula here for permutations, which basically this n to the pk. I know that may look strange to some people, but basically all this formula up here is saying. Let's see if I can get a little better pointer option here. I do have a laser. Oh, there we go. So, what all this formula here is saying is that if we have n things that we want to figure out the number of ways to permute them into k places. So, before we were talking about the 5 people that we wanted to figure out how many ways can we permute them, or how many ways can we distribute them between 5 chairs. And we were saying it was 5 times 4 times 3 times 2 times 1. Well, this is just a generic formula saying that if we have n things that we want to figure out the number of ways to permute them into k places, it's basically n factorial divided by, and it's n minus k all factorial in here in the denominator. Now, there's a special case here where you've got, well, what if you have n things that you want to figure out the number of ways to permute them into n places, which is also represented n to the pn. That formula would be n factorial divided by this n minus n k factorial here. which if you reduce that down, it becomes n factorial divided by 0 factorial. Well, if you look at this and you realize that if you have n things, if you have k equal to n, and you're wanting to have, you have n things that you want to figure out the number of ways to permute them into n places, it works out to being equal to n factorial. Well, in order for n factorial to equal n factorial divided by 0 factorial, mathematicians decided, well, for that to work out in the special case of k equal to n, 0 factorial had better equal 1. So some people may call that lazy. I don't know where anybody gets that idea. I think it's coming from someone who doesn't understand what permutations are. Um, there's a confusion over, what a convention and a law of mathematics is. Some people think conventions are lazy, I guess. The whole order of operations is a convention. When we talk about BODMAS and PEMDAS, it's a convention. We've decided, we have parentheses and then we have our exponents and multiplication and division have equal precedence and they're just solved left to right. You've got addition and subtraction that you follow up with. It's a convention, but it's not an arbitrary convention. And again, I've covered that in other videos, but remember, since multiplication is shorthand for addition and subtraction is nothing more than adding a negative number, and we've already covered the fact that exponents are shorthand for multiplication, so it kind of makes sense that exponents have a higher precedence than multiplication. Division is equivalent to multiplying by a reciprocal, so it makes perfect sense that multiplication and division have equal precedence, right? So the whole concept here of why 0 factorial is equal to 1, why that was chosen as a convention by mathematicians, is because of working out permutations in this special case of, k equal to n. You really needed 0 factorial to be equal to 1 for that to work out. So it's not some random thing. They couldn't have just easily said, well, it's equal to 0 or 0 factorial is equal to 100. There was some reasoning behind it. So I hope you don't have the idea that because it's a convention, it doesn't mean that you don't have to follow it or that it's lazy or anything like that. There's a real good reason, a reason behind it. So anyhow, I hope that's helpful. The bottom line is I hope you understand why the answer to the problem is 7 and it's not 4. And if you're unsure about factorials, please feel free to look that up. It's not something that everybody deals with. A lot of people, if you're just dealing with simple addition, subtraction, things like that, you may never deal in permutations. Permutations comes up a lot. People that deal in probability, mathematics around probabilities, things like that. In my case, I did take one probability course in college, so I had to deal with it there. So I hope this explanation has been helpful. I know the video went on a little bit, but if you got the right answer off the bat, certainly didn't need to watch the rest. But I did want to cover the reasoning behind why 0 factorial is equal to 1, because to this day, I still see people arguing over that and being very confused. So I hope you might have a little better understanding, and I hope everybody's having a great day, and I look forward to seeing everyone in the next video.